Here is grade 7, module 14, lesson 2. I can find an experimental probability and its complement. All right, so we have some vocab here. An experimental probability can be found by dividing the number of times an event occurs by the total number of trials. So it's talking about a specific event occurring out of a total amount of trials, or how many times they tried to reproduce that event. The complement of that event is the set of all outcomes in the sample space that are not included in the event. So for example, we're talking here about a coin that was flipped 20 times. So you have a coin, you're flipping it 20 times, and 8 times it lands on its head. Your event is landing on head, so that's what we're focusing on. So the experimental probability will be our 8 out of 20. If we were to simplify that, 4 goes into both of these numbers. This goes in twice. This goes in 5. So the experimental probability is 2/5. The experimental probability of the complement, like the opposite, okay, we'll say opposite of the event, so that would be landing on tails because we only had 2 possible events here, would be 12 out of 20, because if it didn't land on heads, it had to land on tails. 12 out of 20, which simplifies to 3/5. All right, so we have Megan, and she chooses a marble from a bag 50 times and records the results. So out of the 50 times, so here's our total times, total number of trials. So here's our trials, 50 times, and then records the results. So 26 times she got red. So 26 out of 50 was red. Simplify that. What is that going to be as a simplified fraction? 26 over 50. Pause the video if you need to, no rush. That would be 13 over 25. So cut both those numbers in half. And again, we're doing 26 is the event happening. So the probability of red happening is, or the event that happened, it happened 26 times out of the 50 trials. Now for blue, this happened 10 out of the 50 times. We simplify that to be 1/5. And green, it happened 14 times out of the 50. If we simplify that, they're both even numbers. We're going to get 7 out of 25. Okay, so that is our experimental probability. Okay, experimental probability. Down here, we have a spinner that has 4 sections. There are red, blue, green, and yellow. Andrea spins the spinner many times and records the results in a table. So here we have red. Red has occurred how many times? It's occurred 13 times. Out of how many? Add those up. 13 plus 19 plus 28 plus 10. And we'll get 70. Okay, 13 is a prime number, so that can't be simplified. So the experimental probability of spinning the color red is 13 out of 70. Think experimental probability, not the actual probability based on this experiment. 13 out of 70. And then the probability of blue would be 19 out of 70. And then try green and yellow, write those out, pause the video if you need to. And then try number 2. Find the experimental probability of the complement of spinning yellow. So try and do green, yellow, and then the complement. Pause that video. All right, for green, we're going to simplify that to 28 50ths will get us to 2 fifths. And then yellow will get us 1/7. Now, if the experimental probability is 1/7, then that means the experimental, like kind of what's left, would be 6/7. Okay. Now, which section of the spinner do you think is the largest, and which one is the smallest? And then explain why. So based off of this, our data here, which one do you think is the largest, and which one is the smallest, and why? All right, pause the video if you need to. Largest is gonna be green. Based off of our data, our largest will be green because it had the most results. So it's gonna take up the most space. And our smallest is going to be yellow because it had the least number of spins. Okay, and green because it had the most number of spins. So always include that why, explain your answer.